So we, Townsend Sanidhya, have built this quadcopter and I'll explain how it's working. So right now, this is the initial state when all 4 LEDs are continuously on. This means that this quadcopter is waiting for the remote calibration starting procedures. Now this is the remote that we have procured and these are the joysticks in it. Now the calibration procedure is such that the endpoints of these joysticks are mapped in the STM32 that's visible here. So I'll give the endpoints of these joysticks to the STM32 and then to move out of this calibration state I'll give it a command state. Now this is the verification of the remote calibrations. Now for that a particular combination of inputs has to be given so that it verifies properly. Now all 4 motors have gone into a calibration state and the sound that you saw meant that all these 4 motor ESCs are calibrated to the standard values by this STM. Now after that calibration is being done, the gyro calibration takes place which removes the offset from the gyroscope. And after every calibration takes place, it does a verification of everything, and after that these 4 LEDs start blinking in such a form. This indicates that the drone is all ready to fly and is ready to be armed. Now going to the armed state, we will give it an arm command in which all motors will start rotating at a slow speed. Now giving it an arm command, and then so all 4 motors are rotating slowly. Now there's a unarm command as well which we have implemented here. Is that this for safety precautions, this bottom left will arm it and unarm it. Now apart from that, we have implemented an extra feature which is a debug feature inbuilt in the STM which we incorporated it, and that is in the unarmed phase if we go into the debug mode and then bottom, now this throttle value is mapped to all 4 motors. This gives us a procedure to verify whether all 4 motors are calibrated at the same point. So this is how this quadcopter has been implemented. Now we will show it a demo, and thank you.